NASA says its Voyager One probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Imagine sending a spacecraft into space and expecting it to stop working after only a few years. Instead, Voyager One kept traveling for decades, crossed the edge of our solar system, and then made a discovery that shocked scientists. Even after nearly 50 years, it continues sending back strange information from the dark space between the stars. Some of its latest findings do not fully match what experts expected to see, raising new questions about our place in the universe. What did Voyager 1 detect so far from Earth, and why are scientists still struggling to explain it? Join us to find out. Beyond the Edge. On September 5, 1977, a rocket lifted off from Kennedy Space Center in Florida, carrying a small spacecraft called Voyager One. Its mission sounded simple. It would fly past Jupiter, then Saturn, take photographs, collect valuable information, and continue drifting into deep space until its systems stopped working. Scientists expected the mission to last about 4 to 5 years, and they believed it would end around the early 1980s. It was expected to become a successful but short journey that would give people a better look at the outer planets before falling silent forever. Instead, Voyager 1 began one of the greatest adventures in the history of science. Voyager 1 reached Jupiter in March 1979 and sent back the first close-up pictures of the giant planet and its surroundings. These images gave scientists an entirely new view of Jupiter and revealed details never seen before. After completing that part of its mission, the spacecraft continued towards Saturn. It arrived there in November 1980, collecting more photographs and scientific measurements. As it passed each giant planet, their powerful gravity acted like a giant slingshot, giving Voyager 1 extra speed and pushing it farther into space without using much of its own fuel. The mission kept going long after its planned ending. Year after year, Voyager 1 traveled farther away from Earth than any other human-made object. By the end of the 1980s, it had already become the most distant spacecraft ever launched. Even more surprising, it was still working. It continued sending weak but reliable radio signals across the enormous distance back to Earth. Engineers were amazed that its aging equipment kept performing so well after many years in the harsh environment of space. The spacecraft continued collecting valuable scientific information while moving farther from the Sun than anyone had imagined possible. A truly historic moment arrived in 2012, more than 35 years after Voyager 1 began its journey. The spacecraft crossed the heliopause, an important boundary surrounding our solar system. This event changed the mission forever because it marked the first time any human-made object had traveled beyond the outer edge of the Sun's protective region. Voyager 1 had reached a place that no spacecraft had ever visited before, making history in a way that few people fully understood. The Sun does much more than provide light and warmth. It constantly releases a stream of charged particles known as the solar wind. This steady flow spreads outward in every direction, creating a huge protective bubble around the solar system. Inside this bubble are every planet, every moon, every asteroid, every comet, every spacecraft launched from Earth, and every living thing that has ever existed. The heliopause marks the outer edge of this bubble. It is the point where the solar wind becomes too weak to continue pushing outward because the pressure from interstellar space pushes back. Everything inside belongs to our solar system. Everything beyond it lies in the vast space between the stars. When Voyager 1 crossed this boundary, it became the first object ever sent by humanity into interstellar space. This was not just a symbolic achievement. The spacecraft had truly entered the ancient, dark region between star systems. Even after reaching this remarkable place, Voyager 1 continued sending scientific information back to Earth. Scientists suddenly had a working instrument exploring an environment that had never before been examined directly from the inside. Before Voyager 1 reached interstellar space, scientists had developed detailed mathematical models describing what they believed that distant region would be like. These carefully tested studies suggested that the space between stars should be calm, thin, cold, and mostly empty. According to these ideas, particles would drift quietly through a smooth environment where very little happened. Everything pointed toward a peaceful region with little activity. The real picture turned out to be very different. Beginning in 2017, Voyager One's plasma wave instrument detected something unexpected. It found a faint but steady signal moving through the interstellar plasma. Instead of appearing once and disappearing, this emission continued year after year. It stretched across more than 900 million miles of space. For comparison, the distance between Earth and the Sun is about 93 million miles, making this detected region roughly 10 times greater. Scientists could not easily explain why such a continuous signal existed because their earlier models had not predicted it. Researchers published their findings in the scientific journal Nature Astronomy. Their studies showed that interstellar space is not the quiet and simple place many had expected. Instead, it is filled with movement and structure across many different distances. It contains changing patterns and complex activity that had remained completely hidden before Voyager One entered this region. For the first time, scientists could study the space between stars using direct measurements instead of depending only on observations from Earth and mathematical predictions. These discoveries changed the way scientists think about the universe beyond our solar system. For many years, understanding of interstellar space came from telescopes, calculations, and scientific theories. Voyager One provided something far more valuable. It offered real measurements from inside that distant environment. Those measurements revealed that interstellar space is more active, more detailed, and more complicated than earlier ideas had suggested. So what secrets did the Voyager One uncover? Stay with us to find out. The spacecraft that refused to fall silent. In 2023, something happened that nearly ended the incredible journey of Voyager One. The famous spacecraft was still sending a signal back to Earth, but for 5 long months, the information it sent made no sense. The data was scrambled, broken, and impossible to understand. Engineers at NASA's Jet Propulsion Laboratory had spent decades studying every message Voyager One had ever transmitted, yet this strange signal was unlike anything they had seen before. The most surprising part was that the spacecraft itself was still alive. Its radio signal continued to arrive on Earth exactly as expected. However, the scientific information hidden inside that signal had become unreadable. The team knew Voyager One was trying to communicate, but they could not understand what it was saying. For a mission that had been operating successfully since 1977, this was a frightening mystery. After many careful investigations, the engineers discovered the cause. A single memory chip inside the spacecraft had slowly worn out after almost 5 decades in space. Tiny particles of cosmic radiation had damaged it little by little over the years. That small chip was responsible for helping Voyager One organize and send its scientific data. When it failed, the information became corrupted before leaving the spacecraft. No alarm had warned the team. No emergency message had appeared. The chip simply stopped working properly after 46 years of non-stop operation in one of the harshest environments imaginable. On Earth, a broken part can usually be replaced by a technician. But Voyager One was not on Earth. It was about 15 billion miles away, far beyond the reach of any repair mission. The engineers had only one way to help the spacecraft: radio signals. Even that was difficult. A message sent from Earth took about 22 hours to reach Voyager One. If the spacecraft replied immediately, the answer needed another 22 hours to return. Every single test required at least 44 hours before the team could see the result. Imagine how slow and careful the work became. The engineers would study the damaged data and create a possible explanation. They would write instructions to test that idea and send them across space. Then they waited 22 hours. After that, They waited another 22 hours for the response. Only then could they see whether the test had worked. If the result was unexpected, they had to begin the process again. This continued month after month. Every instruction had to be written with extreme care because one serious mistake could permanently end the mission. The spacecraft was too far away for a second chance. The team at Jet Propulsion Laboratory worked patiently, checking every detail before sending each command into the darkness between the stars. Finally, they found a solution. The damaged memory chip could not be repaired, but the software stored there could be moved. The engineers divided the affected code into smaller pieces and placed those pieces in other parts of Voyager 1's remaining memory. Each section was tested carefully to make sure it worked correctly in its new location. Then, the sections were connected together again so the whole system could operate normally. It was an amazing achievement. The engineers had performed the equivalent of delicate brain surgery on a spacecraft nearly 50 years old while communicating through a delay of 44 hours. And they did it successfully. In the middle of 2024, Voyager 1 began sending clean and readable scientific data again. The spacecraft that many people thought might never recover returned to life. Even more remarkable, it immediately resumed reporting on the strange plasma waves and turbulent conditions of interstellar space that scientists were still trying to understand. Voyager 1 had been expected to fall silent in the early 1980s. Instead, after nearly half a century in space, it survived another crisis and continued its lonely journey beyond the edge of the solar system. The secret revealed. For many years, scientists carefully studied the heliopause, the outer boundary of our solar system. Using mathematics, computer models, and observations from Earth, they believed they understood what a spacecraft would experience when crossing this distant region. According to their predictions, the change would happen slowly. The solar wind flowing outward from the Sun would gradually become weaker, while the particles from interstellar space would slowly become stronger. Scientists expected a smooth transition where one environment gently blended into the other. When Voyager 1 finally reached the heliopause, the spacecraft showed that reality was much more surprising. Instead of finding only the gentle change that scientists had expected, its instruments detected a far more active and complex boundary. The region was filled with energetic charged particles and changing conditions that did not match many earlier predictions. The edge of our solar system turned out to be a much more dynamic place than anyone had imagined. Scientists had believed this distant area would be fairly calm because it lies so far from the Sun. Instead, Voyager 1 revealed that the boundary is shaped by powerful interactions between the solar wind and the material found in interstellar space. These particles constantly influence one another, creating a region that is active rather than quiet. Although space there remains extremely thin, the physical processes taking place are much more complicated than researchers once believed. One of the biggest surprises involved the magnetic fields surrounding the heliopause. Before Voyager 1 arrived, scientists expected a dramatic change. They believed the Sun's magnetic field would end at the boundary, while the galaxy's magnetic field would begin beyond it. The two regions were expected to be clearly separated, with each having its own distinct magnetic direction and behavior. Voyager 1 discovered something different. The measurements showed that the magnetic fields on both sides of the heliopause were closely connected in ways that existing theories had not fully predicted. Instead of acting like two completely separate systems, the Sun's magnetic field and the magnetic field of interstellar space interacted with each other near the boundary. Scientists explained this surprising behavior through a process known as magnetic reconnection. During this process, magnetic field lines from different regions come together, break apart, and reconnect in new ways. As this happens, energy is released into the surrounding environment. This process is already known to occur in many places throughout space, but Voyager 1 provided valuable evidence that it also plays an important role near the edge of our solar system. This discovery changed the way scientists think about the relationship between our solar system and the wider galaxy. Instead of being completely isolated inside its own magnetic bubble, the solar system appears to remain connected to the space beyond it. The boundary is not simply a dividing line. It is an active region where different magnetic fields interact and exchange energy. These findings were far more important than a small adjustment to earlier scientific ideas. They showed that the heliopause is much more complicated than researchers had believed for many decades. The spacecraft provided the first direct measurements from this distant location, giving scientists information that could never have been collected from Earth alone. The discoveries also have important meaning for our own planet. The heliosphere, created by the solar wind, helps shield the solar system from many high-energy particles traveling through the galaxy. If the boundary surrounding this protective bubble behaves differently than expected, scientists must carefully examine how well this shield works over very long periods of time. Understanding these changes may improve future models describing how the solar system interacts with the environment beyond it. Voyager One continues to provide information that challenges long-held ideas. Even after traveling farther than any other human-made object, the spacecraft is still helping scientists learn about regions that were once completely unknown. Every new measurement improves our understanding of the enormous space surrounding our solar system and reveals that the universe is often more complex than our best predictions. But this discovery didn't just bring progress. It brought a realization and severe decision to be made by the world. What issue did it bring? NASA's toughest choice. Earlier this year, NASA made one of the hardest decisions in the history of the Voyager One mission. The spacecraft's low-energy charged particle instrument, which had been collecting valuable scientific information almost continuously since 1977, was turned off. The surprising part was that the instrument had not failed. It was still working properly. The only reason it was shut down was because Voyager One no longer had enough electrical power to keep every system operating. After traveling through space for almost 49 years, the spacecraft was slowly running out of energy. Voyager One receives its electricity from 3 radioisotope thermoelectric generators. These power systems contain plutonium-238, which naturally produces heat as it slowly decays over time. That heat is then converted into electricity, allowing the spacecraft to operate its instruments, computers, and communication systems. When Voyager One launched, these generators produced about 470 watts of electrical power. Today, after many decades in deep space, they produce only about 250 watts. Every year, the available power becomes a little lower as the radioactive material continues its slow decay. Scientists have known for many years that this moment would eventually arrive. The spacecraft cannot create new power, so every remaining watt has become extremely valuable. Because of this, the mission team carefully planned how to keep Voyager One operating for as long as possible. Long before the power became critically low, engineers and scientists worked together to decide which systems would remain active and which would eventually need to be turned off. Their goal has always been to collect as much scientific information as possible before the spacecraft reaches the end of its working life. Voyager One originally carried 10 scientific instrument packages when it left Earth. Over the years, 7 of those instruments have already been switched off to save electricity for the remaining systems. Every decision has required careful thought, because once an instrument is turned off, it may never be used again. If the available power continues to decrease, there may not be enough energy to restart it later. Each instrument represents years of scientific work and the opportunity to answer important questions about space. Turning one off means giving up some discoveries that might never be made. Current estimates suggest that sometime during the early 2030s, the spacecraft's power supply will become too weak to operate any of its remaining scientific instruments. When that happens, Voyager 1 will no longer be able to collect new scientific information. Eventually, it will become permanently silent after one of the longest and most successful missions ever completed. Even so, the mission team has not stopped searching for solutions. Engineers at NASA are continuing to study ways to extend the spacecraft's life. One experimental effort has reportedly been called the Big Bang procedure. The idea is to reorganize how electricity is shared among Voyager 1's remaining systems. By improving the way power is distributed, engineers hope to recover a small amount of additional electrical capacity from parts of the spacecraft that are not operating as efficiently as they could. This is an extremely difficult task. Voyager 1 is nearly 50 years old and is far beyond the reach of any repair mission. Even a small mistake could create unexpected problems because there is no way to manually fix anything once a command has been sent. Every change must be planned with great care before being transmitted across the enormous distance separating Earth from the spacecraft. To reduce the risk, NASA plans to test the procedure first on Voyager 2. That spacecraft still has slightly more available power and is closer to Earth than Voyager 1. If something unexpected happens during testing, the consequences may be easier to manage. Tests were scheduled for May and June of 2026. If the results show that the procedure is both safe and successful, engineers hope to attempt the same approach on Voyager 1 no earlier than July of this year. If the procedure succeeds, there is a real possibility that the low-energy charged particle instrument, recently turned off to save power, could be switched on again. The mission team remains careful and realistic, making no promises about the outcome. Still, they continue working because Voyager 1 has surprised the world many times before, proving that its remarkable journey is not over until the spacecraft finally falls silent. The Voyager 1, an incredible milestone. On November 18, 2026, at 16 minutes and 12 seconds past 2 o'clock in the morning Pacific Standard Time, Voyager 1 is expected to reach an extraordinary milestone. It will be exactly 1 light day away from Earth. This means that even a signal traveling at the speed of light, the fastest speed known in the universe, will need a full 24 hours to reach the spacecraft. It is a remarkable distance that no human-made object has ever reached while still operating and communicating with Earth. At that point, every conversation with Voyager 1 will require great patience. If engineers send a command on a Monday morning, the signal will not arrive until Tuesday morning. If the spacecraft immediately sends a reply, that response will not return to Earth until Wednesday morning. A simple exchange of information will take 2 full days. Every instruction, every test, and every scientific operation must be carefully planned because there is no quick way to correct mistakes across such an enormous distance. Even after reaching this historic point, Voyager 1 will continue moving farther into interstellar space. Every hour, it travels about 38,000 miles away from Earth. As the distance grows, communication takes even longer. At the same time, the spacecraft's electrical power continues to decrease little by little. Scientists know that sometime during the early 2030s, Voyager 1 will eventually send its final transmission as its remaining power becomes too weak to operate its systems. That final message will not mark the end of Voyager 1's journey. The spacecraft will simply continue moving through the darkness of interstellar space. There is almost nothing there to slow it down. There is no atmosphere creating resistance, no friction to reduce its speed, and no nearby gravity strong enough to pull it far from its path. Voyager 1 will continue traveling in a nearly straight line at about 38,000 miles per hour, silently crossing the space between the stars for an unimaginably long time. Attached securely to the spacecraft is one of humanity's greatest symbols of hope and curiosity, the Voyager Golden Record. This gold-coated copper disc carries greetings spoken in 55 human languages. It also contains the sounds of rain falling in a forest, ocean waves reaching the shore, and people laughing together. Along with these sounds are about 90 minutes of music chosen from many cultures around the world. The record also includes simple scientific diagrams explaining important ideas in mathematics and physics, along with a map based on the positions of pulsars that shows the location of Earth within the Milky Way galaxy. The Golden Record was created as a message from humanity to anyone who might discover it in the distant future. It represents a civilization that explored, learned, and reached beyond its home. It tells the story of a species that built a machine using science, engineering, and imagination, then sent it beyond the planets, carrying sounds from its own world. Long after the spacecraft stops communicating with Earth, the Golden Record will continue its silent journey through the galaxy. The record may outlast almost everything humanity has ever built. It will continue traveling even after countless generations have passed. It could remain in space long after many familiar parts of our solar system have changed. It is one of the most enduring objects ever created by human civilization, carried by a spacecraft that now operates using less electrical power than many everyday household lights. Voyager One is still making important scientific discoveries as it continues this remarkable journey. Since 2017, the spacecraft has detected a steady plasma emission in interstellar space. Scientists studying these measurements believe they represent the first continuous observations of interstellar plasma density ever collected by humanity. Before Voyager 1 entered interstellar space, researchers could only measure plasma density occasionally. Most earlier measurements happened after powerful eruptions from the Sun sent shockwaves across the solar system and into space beyond the heliopause. Those observations were useful, but they provided only isolated moments instead of a complete picture. Voyager 1 changed that completely. Instead of collecting occasional measurements, it now provides a continuous stream of information as it travels farther from the Sun every day. These observations allow scientists to watch changes in interstellar plasma over time rather than seeing only brief snapshots. This ongoing record is helping researchers understand the true nature of the space between the stars. But there's one question still left unanswered. Stay with us. The one mystery Voyager 1 has not solved yet. Even after all the discoveries made by Voyager 1, one important question still remains unanswered. Scientists studying the spacecraft's data have found a mysterious and continuous signal in interstellar space, but they are still trying to understand exactly what is producing it. After years of careful research, two possible explanations remain, and no one has yet been able to prove which one is correct. The answer could help scientists understand the space between the stars in a completely new way. The first possibility is that the signal comes from naturally occurring plasma oscillations. Plasma is made of charged particles, and these particles can vibrate as they interact with their surroundings. If this explanation is correct, it would still be an important scientific discovery. It would improve our understanding of interstellar space, while remaining consistent with the physical theories scientists already use to describe the universe. In this case, existing scientific models would become more complete without requiring major changes. The second possibility is even more exciting. Scientists believe the signal could instead be produced by a process called quasi-thermal noise. This physical effect carries information about the density and temperature of plasma in a different way. If this explanation proves to be correct, researchers may need to make significant changes to their current understanding of the interstellar medium. Many scientific models describing the space between the stars would have to be carefully revised to match the new evidence collected by Voyager 1. Finding the correct answer will not be easy. Scientists need additional observations to separate these two possibilities. The best source of that information is Voyager 1 itself. However, every passing year makes this task more difficult. As the spacecraft slowly loses electrical power, more scientific instruments must be switched off to keep the mission alive. With fewer instruments collecting data, the opportunity to solve this mystery becomes smaller. Another solution would be to launch a completely new spacecraft designed specifically to study interstellar space. Such a mission could carry modern instruments built to answer these questions with far greater precision. Unfortunately, no mission of this kind is currently operating, and none is currently funded. Even if a new spacecraft were approved, built, and launched today, it would still require at least 25 years to reach the heliopause and enter interstellar space. That means Voyager One remains humanity's only direct scientific observer in this distant region. Because of this, scientists know that time is becoming increasingly valuable. Eventually, Voyager One will fall silent as its power supply continues to decrease. The exact date is still unknown, but engineers understand that the end is slowly approaching. Every year brings less available electricity. Every year forces another difficult decision about which systems can continue operating. Sometime during the early 2030s, the remaining instruments will no longer receive enough power to function. One day, the final signal will begin its long journey back to Earth. After traveling for about 24 hours, it will arrive at NASA, and there will be no message after it. Even then, Voyager One will not stop moving. The spacecraft will continue traveling through interstellar space at about 38,000 miles per hour. Attached to it will remain the Voyager Golden Record, carrying sounds, music, greetings, and scientific information from Earth as it continues its endless journey through the galaxy. The story of Voyager One began on a morning in September 1977. Engineers launched a spacecraft that they expected to operate for only about 5 years. Instead, it has continued exploring for nearly half a century, making discoveries that no one imagined possible. Today, in 2026, humanity still depends on this remarkable spacecraft to study interstellar space. Voyager One was built before personal computers became common. It now operates using only a tiny amount of electrical power, yet it continues sending information that is changing how scientists understand the universe. Humanity has built larger spacecraft, more advanced machines, and more expensive missions, but none has traveled where Voyager One has gone. None has crossed the heliopause and entered the space between the stars. Some questions cannot be answered by telescopes on Earth, satellites in orbit, or spacecraft exploring planets. They require direct measurements from deep interstellar space. At this moment, humanity has only one spacecraft capable of providing those answers. As long as Voyager One continues transmitting, scientists will continue listening. Every signal carries valuable knowledge about a universe that is more active, more connected, and more surprising than anyone once believed. When that final transmission arrives, humanity's only direct window into interstellar space will close, leaving future generations to continue the journey that Voyager One began. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.